Bismillahirrahmanirrahim. Assalamu alaikum. Welcome you all to the second part of the fourth lecture. My name is Engineer Jaffar Ali. Let's start where we left in the previous class. So in the previous lecture, we have discussed about the transport layer and the types of delivery, that what is node to node delivery, what is host to host delivery, and at the end, what is process to process delivery. Now we will start another topic that is provided as service that is provided by the transport layer, and that is known as UDP.
Now coming towards the UDP, that is user datagram format. Let's start with the formatting, that what is the shape or what is the format for the UDP datagram packet. So UDP datagram packets are normally termed as UDP user datagrams. This is very important to know. In IP, you will also see that in a network layer or IP layer, IP packet is normally termed as IP datagram. The IP packet is normally termed as IP datagram. Similarly, in in this transport layer, UDP packets are termed as user datagrams. It consists of some data, and there are several other control bodies that are involved in the UDP. So it has a fixed size of 8 byte. So the header, you can see there is a header that is of 8 bytes, and this header is basically of UDP. This is UDP header, and this is as a whole is the user datagram. This is your user datagram. This big thing, this is your user datagram, and it involves a header. Header is basically, you can see that several information that is stored. I have discussed about the header in the previous lectures as well. That header is a kind of information holding or monitoring or logs that is kept for the maintaining or monitoring a logs, and to let others know that what you are doing and what you are processing at what amount, so that others should also make themselves compatible to your packet or your communication kind of communication. So a header involves a source port number that is of 16-bit, a destination port number that is of 16-bit as well, total length of the the datagram, that what is the length of the total datagram for 16 bits, and checksum for 16 bits. So now you can see that this is responsible for the flow control, these two bodies, and these two bodies are responsible for the error control. So now I'm asking, take a moment and think that how this information is useful to make error control processes more easy and efficient. So take a moment, pause the video, and think about that what this information is providing, what kind of help. So I'm going to tell you about this. If you have come with the idea, it's good. But if you haven't, let's discuss it. So at the receiving end, let's say if you have received receiver has received a packet, and let's say due to some noise burst or some channel irregularities, some data has been lost. The data has been lost. Let's say this amount of data has been lost. So how will the receiver know that the data has been lost? Because receiver does not know about the incoming data. So it will think that the data is up to here, and let's say 2 or 3 bits will be lost due to the error, noise, or the bad performance of the channels. So who will tell the receiver that the data is missing? So basically data will look into the header, and it will see that, let's say the length of the data is 16, and it starts with, let's say, zeros, all zeros, and in there are, let's say, 12 zeros, and the last 4 bits are actually 1 1 1 1 1. So these 16 bits will be embedded in this. So it will show the length of the total datagram, this whole datagram. Now and this the length of the datagram is basically, you can see that it is actually 16 bytes. So let's say the user has sent the information, and the transmitter has sent some data, user information of 16 bytes. Now, how the receiver will know that there is 16 bytes? Let's say due to some error or noise in burst, there are some lost packets, and let's say 2 bytes are lost. So how will the receiver know that the data is only, and the receiver is receiving 12, 14 bytes? So how come the receiver will know that there are, the transmitter actually sent 16 bytes instead of 14 bytes? So receiver will think that the transmitter has sent 14 bytes, but the transmitter has sent 16 bytes. So who will tell the receiver that there are some lost in the packets? So receiver will actually look into the header, and it will see that the header bits, if the header bits are as it is, let's say there are no noise in the header information, and the receiver will see that, oh, the transmitter has set basically 16 bytes, but I have received only 14 bytes. So it means that there are two packets that are lost due to some channel fluctuation, or bad channel, or any noise burst. So receiver will ask the transmitter to resend the data or some packets towards their to the receiving end, so that it will come up with a good result. So this is basically done by these things, and for error control. Similarly, you can also use checksum. If you want, this thing is used to check if the packets are lost or not. If you want to check the packet lost, you can use this information inside the header. And if you want to check that the bits, let's say the bits has been toggled, let's say the bits, the data bits, one, let's say there was a bit of 0 and it has become 1 now. So who will make sure that, because this thing is just counting the quantity, it is not counting the amplitude of the bit. So who will make sure that this 0 cannot become 1, and this, there is a 1 that should not become 0? So this checksum will make sure that there are no toggling in bits or errors. So this is known as your error control, and this thing is basically your also error, but this is due to lost, this is basically due to lost packets, and this is due to toggling of the bits. So by combining these two things, you can see that a user datagram or a transport layer is actually providing error control mechanism in its service. Now, UDP port number, source port number is, this is a port number used by the process running on the machine. So as I've showed you in the previous diagram, that every process has different applications. These, let's say this is your Facebook, and this is your, again, YouTube, on which you are accessing my video. So let's say so let's say the this process has been using port 1, and this process is using port 2. So this is the basically the port number that are assigned, source port number that are assigned by the machine to the process. And this port number is 16-bit long. It means the port number can range from 0 to 65535. It means that your port number can range from, because it's 16-bit long, so there is a combination of 2 power 16. So it will go from 0 to 65536. So if the packet is source host is a client, let's say, and if a formal port number is chosen by the UDP for a particular process requested. So it means that if you are requesting a Facebook, so the receiver will and the receiver has responded to your Facebook query, so it will be coming to your the system, and system will forward it to the your mentioned port. Let's say your port number is 55, so you will be receiving that in 55. Let me show you an example. Let's say this is my there is an application that I use for connecting my mobile to my laptop as a webcam. So this is, you can see that this is my IP, and this is the port number that this application use for connecting my mobile camera to this any application that I'm using in the uh, laptop. So this is the port number, actually this is the process number, that is 4747. So this process number cannot be same with, let's say there is another application, let's say there is another application like Zoom. So I cannot use the same port number with that process as well. So this is about port number. And if the source host is server, the port number is well known port number. Let's say this is your server, this is your server, and this is a Facebook server, or this is a YouTube server. So port number of this will be well known, because this is your personal port number and no one will know about this personal port number. But YouTube and Facebook are multinational organizations, and they are providing services to several billions of users at a time. So their port number will be visible to most of the users in the internet. Let's say the port number of YouTube is 57. So this will be visible to many clients, because there are many clients of Facebook and YouTube at the same time. So the port number will be well known if the host is basically a server. Now, what is destination port number? This is basically also the same, but it is on the receiving end side, and it is also 16-bit long. And if the destination host is server, there is a most probable chance that the port number will be well known to every user across different regions, because most of the our Facebook data or YouTube data is coming from America or Europe. So the server will be well known. I have shown you using CMD in the last class. If you haven't learned about the trace route, that how can you route, you can see that which packet, the packets of Yahoo is coming from which network actually. So I am not connected with internet right now. So you can also use this command to see that which server is used, is responding your email. And by using the classes of IP, you can easily find out that the server is placed at which part of the world. Similarly, if the destination host is a client, that is you are a client, the port number will not be well known. It will be a formal port number, and no one outside your network will be able to know that. Maybe you also do not know that. Most of the people do not know their port numbers, that which port number they are, which port they are using for using Facebook or for using YouTube. So every different application or process creates another port number, different port number, unique port number, so that the system will know that the Facebook data or the YouTube data has to be reached to their accurate places. You do not want your Facebook data to come on the YouTube, or you do not want your YouTube data to pop into your Facebook page. So that is why there is a port number involved. And if you are on a destination side, you are a host, you are not a server, you are receiving a response actually. This port number will be not visible to most of the users, and even sometimes not to you as well. So coming towards the length of the UDP, the UDP is basically 16-bit long. You can see that the total length of the user, you can see that I have told you already that this header and this is your complete user datagram, which includes data and header. It is mentioned that it includes data and plus header, or header plus data. So by combining header and data, you receive a user datagram. And checksum, you also know that checksum is basically to detect errors. You use checksums to detect if the packet or the bit is toggled from 0 to 1. So who will tell the user or the receiver that there are some errors in the packet? So checksum will be there, and it will provide the error correction or error detection policies to the receiving end, that it will know that there is some error in the received packet. Now we will look at some applications that are provided by the UDP. So I have told you that UDP is more efficient if you are using some applications that involves fast delivery. So it is most suitable that for that process, which requires simple request response communication to with a little concern for the flow and error control. You do not concern about the flow error control, you just want fast delivery. So for fast delivery services applications like live streaming and or multiple gaming, you want your packets to be delivered and received very fast in less time, so you do not care about the flow control and error control. So UDP is suitable for transport protocol for multicasting as well. If you are using multiple casting, you want to transmit your packet to several users, and that too within a less time, you can use UDP as well. So UTP is also used for management process as well. We will discuss that in the class or in the coming lectures, inshallah. And in the last major application that is provided by the UTP is that it is used for route updating protocols such as RAP. This is route updating protocol, RAP. And UDP is achieved. UDP is used by several routing protocols, and you will have to tell the network IP or network layer or the IP layer that you are using UDP, so that it can choose a protocol for you that is also compatible with UDP. If you are using TCP, so and you want your network layer to know that, so you have to tell the network layer that I am using UDP at the transport layer, so you have to provide me a protocol that is compatible with UDP. So it should not provide you IP or any other protocol that is basically incompatible with TCP. So you have to tell the network layer or the IP layer. So let's get started with a very good example of the UDP. You have seen you can see that the content of a UCP UDP header is in hexadecimal format, and it is mentioned over here. This is the your one of the header, and you can see that this is basically 16-bit long. So it is the basically the information of the header. Header contains this information, and using this information, how can you find the source port number, how can you find the destination port number, how can you find the total length, and how can you find the length of the data. So it is asked, I've shown you that UDP header contains this information. So how will you extract the information from the UDP header? So let's get started. So the first four hexadecimals are basically the first four hexadecimals are the source port number. So if the first four numbers are, let's say, CB84, and this is in hexa, so you just have to convert that into decimal, and you get 52,100, 52100. So your port number for the source is basically 52100. You have taken the UDP header and you took the first 4 bits and converted into the decimal. So you get the first thing, that is your source port number. Similarly, the destination port number is the second 4 bits, that second 4 digits of your header information, and you just have to convert that into decimal again. You get destination port address. Similarly, the third four hexadecimal digits define the length of the whole UDP packet. So if it is mentioned that this is the these are the these are the next third four hexadecimal digits. So by using this, you can know that by converting that into the decimal, you get 28. So it means the length of the whole UDP packet is 28 bytes. And if you know that there are 8 bytes, we have learned about the this thing, that the header of a UDP is always 8 byte. So if you have you have received the length of the whole datagram, you can easily find the value of the length of the data actually. So the total packet was, it is we have found that the total packet is of 28 bytes. The whole packet is, which includes data and data and the header. There is header and this is the data, and we have found that the total length of this file, this datagram, is actually 28 bytes. So you can now easily find the length of the data actually. You want to find the length of this data, so you can subtract 8, because you know that the length of the header is 8. So if you minus 28 from 8, you get 20. So the length of the data is basically 20 bytes. You can see that here you have done the same thing. The total length is 28, and you know that 8 of that bytes are from header portion. So you have subtracted 28 8 from 28, and you get 20 bytes. It means this data will be comprised of 28 bytes. So there are some other features. These are some features that are provided by the UDP. The first one is process-to-process communication. We have discussed that. We have also discussed connectionless services. We have done flow control. It doesn't provide flow control, but it provides some error. It is mentioned that it doesn't provide error control except for the checksum. So that is also part of the error control. So it kind of provide you the error control mechanism. It provides you checksum. It provides no congestion control. We will discuss that what is congestion control in the coming slides. It provides no. It provides encapsulation and decapsulation. It provides queuing. It provides multiplexing and demultiplexing. These are some features that UDP provides to a user. So that's all for today now. Think that this was enough for today's class, and I look forward to your good questions. I will be happy to answering your some technical and conceptual questions. Do write in with yourself, and inshallah I'll see you in the class. Come up with the good questions. That's all for today. Allah Hafiz.